For our second question, we have a scrap paper and then we cut them into 4 equal side squares. Okay, so this means for the first round, we have 1 square. Then since we cut it into 4, so the second round we have 4 squares. Then the process keeps on repeating. So this means for each square later on, we also cut them into 4 equal size squares. Okay, so this means for the third round, for each square we cut into 4. So this means in total, the third round we have 16 squares, and this process will keep on repeating. So for part A, we need to show that this process, or meaning the number of squares, follow a geometric progression. But how do we prove this? Right, so let's identify one of the differences between arithmetic and geometric. So arithmetic, they will use common difference, because if you want to find the next number, it will always be adding or minusing a value. But for geometric, we look at common ratio, because to get the next number, it's always multiplying or dividing. Right? So for this one, if you want to prove, let's calculate 2 ratios but using different values to find them. If let's say these 2 ratios is the same, this means it is a geometric progression. If it's not, that means it is not a geometric progression. Okay, so let's find out these 2 ratios first. So for the first ratio, what I will do is use the second term, which is 4, and the first term. Okay, so recall back, to find the ratio is always, if you choose this value, divide with the previous value. So t2 divided by t1, or 4 divided by 1, which is 4. Then for the second ratio, R2, so you divide the third term divided by the second term. So third term is 16, second term is 4. So 16 divided by 4 is 4. Right, so now you see that these 2 ratios are the same. So we can conclude that since R1 equals to R2, the number of squares cut forms a geometric progression. So the main idea here is find 2 ratios using different values. If it's the same, means it is a geometric progression. And for part B, we need to find the total squares obtained if the process keeps on repeating for 6 times. Right, so let's go to the 3 questions framework to figure out which formula should we use for this question. So for our first question is, if we want to find the next value, do we need to multiply or divide a value? So for our case, T1 or the first round, we have 1 square. T2 or the second round, we have 4 squares. T3, we have 16 squares. So to find the next value, we need to multiply 4. So the answer is yes. And we have already proved in part A that this is a GP. And the second question is, does it involve sum? So in our question, there's a keyword here which is total. So most of students will think that if I see total, that means it involves sum. So that's why I need to use the SN or S infinity. Okay, but sometimes when we add stuff, let's examine whether the adding the numbers does it make sense or not. Okay, so for our case, so for round 1 we have 1 square, and then we cut 1 time, we will have 4 squares. So if we want to add 1 plus 4, it doesn't make sense, because this square has already transformed into 4 smaller squares. So this one is non-existent anymore, does not exist. If let's say we go from the second to third round, after we cut 1 time, it will become 16. This 16 actually comes from the 4 squares. So once we cut, this 4 also disappears. And the final number of squares that we have at the moment is 16. It's not 1 plus 4 plus 16. So what I understand from the total here is, it doesn't represent the total number of squares after each and every cut, but it's more like the total number of squares after that particular cut. Right? So for example, if I cut 2 times, the total number of squares is 16. It's not 1 plus 4 plus 16, because 1 plus 4 is not existent anymore. Alright, so if it's 16, this means we only look at that term only, which is why for the second question, it's a no. And if you want to solve the question, we need to use the Tn formula in GP. Alright, so Tn in GP will be this formula, and now we need to figure out the value of n. So let's draw out a progression line to see once we cut 6 times, what is the term. Alright, so for the first term is T1. Okay, if I cut the first time, I will get T2. Second time will be T3. Third time I cut will be T4, and so on. So once I go to the 6th cut, what is the term? So here you can actually look at the pattern. So let's say here this is the 3rd cut, or 3. We get the 4th term, which is 4. So 3 plus 1, 4. So here will be 6 plus 1, 7. T7. So we need to find the 7th term. Right? So A we substitute 1, and R we substitute 4. From here, the 7 I substitute here, then we will get the answer is 4096. But do take note that this answer is different from the textbook answer. Textbook answer is S6. Okay, so there are 2 errors. First thing is why use S? The second error is why use 6. Right, for S, like I've mentioned previously, we shouldn't add the number of squares from the previous rounds because it's non-existent anymore. For example, 1 square, if I cut into 4, and if I want to find the total number of squares, I shouldn't add 1 because this one has already been cut. Okay? And for the 6, okay, this one I think a lot of students will make this mistake also because they look at the 6 here. If they look at 6, then they think, oh, it should be T6 or S6, which is wrong. Okay, so what I suggest is to draw out this progression line to see after the 6th cut, what would be the correct term of the correct sum. Alright, so this one clearly it's 7. So after the 6th cut, so we should use 7 instead of 6.